Okay, let's look at let's look at this here. Okay. We got P equals 90 e to the negative 0.5 t. Okay, if we look at the last slide, I'll just step off. That 90, right? We talked about that being the initial value. Okay, if you think back to the last slide, e is that constant 2.7. Negative 0.5 is our growth or decay constant, right? And t is time. That's another variable. T is time. Okay? So what we need to do, if we look at number one, question is this. What is the diastolic pressure when the aortic valve is closed, which t equals 0? Okay? So they've told us that t equals 0, so we need to find the pressure when t equals 0. Okay? So I can do this, 90 e. I know that negative 0.5 times 0 is 0, so I don't even need the calculator here. Well, now I know that e, so it's that crazy constant 2.71 and it goes on and on. Okay? But anything to the 0 is 1. So that's 90 times 1 and p equals 90. Okay? Now that's what we got for an answer there. Okay? It makes sense because the initial value occurs when time is 0. Well, time is 0, so at the very starting point we need to get the initial value as our answer. So that 90 makes sense, right? Question 2, okay, it asks us to look at when t equals 0.3. Okay? So when t equals 0.3, what we would do is question 2 here. We got 0.3. Okay? I'll just step aside here for a second. Okay. All right. So we will never be able to take e to an exponent without a calculator. So we might as well get right to the calculator because this can be done all in one step. Okay? I can say 90 times e to the exponent. Your exponent key might look a little different, right? Bracket negative 0.5 times 0.3. All right, and see where we end up. Right? Because why do we have the 0.3? Well, when I look, I need to put 0.3 in for the time. Now remember, you have to put this in carefully. I need these brackets because BEDMAS says it'll do the multiplication. It'll do the brackets first, then it'll do the exponent, then it'll do the multiplication. So if you've entered it correctly, you will get 77.46. And then you can answer the question. The diastolic pressure, is it diastolic? Yeah, the diastolic pressure at 0.3 seconds, I've substituted in 0.3, and I would get, we should put a p in front, p equals 77.46. So again, we're focused on the substitution, and that's really all that we're focused on is substituting in for t and getting our answer correctly.